Alright, so today we're talking about missing number. Given an array nums containing n distinct numbers in the range 0 to n inclusively, return the only number in the range that is missing from the array. Basically, it builds off the cyclic sort problem that I did yesterday. And yeah, basically you just want to sort them in order, and so there will be a number missing either in between or at the very end of the array, and you just want to find out which one is the one that we're trying to just find out the missing number, right? So we're going to iterate through this with a while loop. So we're going to initialize wait, why is that red? I is equal to 0. Okay, kind of weird. Since we're using a while loop, we need to initialize the iterator outside of the loop, right? While I is less than the length of nums. This is just to make sure we don't go over. J is equal to nums I. I can explain this in a little bit. Actually, no, I can just explain it now. Basically, we want this value, and we're going to use it to check to make sure we're putting the value in the right place. For example, nums, when I is 0, num sub I is 3, right? And for 3, we want to, actually no, 3 is probably the wrong number to use. I'll use this one instead, because 3 actually doesn't belong inside of this array, quote unquote, because if we were to sort this numerically and we have the numbers, we'd have 0, 1, 2, not 3, right? So 3 is more of the exception, so I'll cover that right after. So if I is equal to 1 and num sub I is 0, right? But since we want to sort this in order, starting from 0, 0 should go into the first index, or like 0, and num sub 0, right? So basically, we're going to use this as a way to check if nums I does not equal to nums j. So basically, this condition will just check whether or not this is in the right index, and if it is, then we won't do anything, right? And if it's not, then we're going to perform swap. And so coming back to the 3 example, the reason why this is sort of like a exception is because, like I mentioned earlier, if we sort it in order, it would be 0, 1, 2, and 3 doesn't necessarily belong in this array, like because 0, 1, 2, and 3 would live right outside of the array, right? So if we were to see this case, instead of, even checking this, because there is no num sub 3, right? Because that's outside of the array, we want to make sure if j is if j is less than the length of nums, and that, then we perform a swap. Because if j would be if I equals 0, num sub 0 right now, j would equal to 3, right? And since we can't check the third index here, we would get an outer bounds array. We need to do this preliminary check to make sure that j is actually less than the nums, just so we can access that index. So if num sub I does not belong where it currently is, we're going to perform a swap. So nums j nums I is equal to nums I. Okay, no, I'm going to do it the other way around. Nums I nums j is equal to nums j nums I. So this is just like a really simple way for us to do a swap. This is something that Python does allow us to do, which is really nice. Okay, I guess it doesn't auto format that. So else, if we don't want to do a swap, then we're just going to increment it. So this could happen in 2 cases, right? In the first case where it's too big, we just ignore it, because as long as we find the right numbers to belong to the space, like for example, actually I'm not gonna, we'll just use this, right? So this doesn't belong there because of this, then we'll just I plus equals 1, so we'll go here, right? So once we go here, we realize that this isn't in the right place. So then it would swap, so it becomes 0, 3, 1. And then that's how we'll just keep swapping it, and then like that's how we'll figure out like, oh, you know, this is we're actually doing the swapping correctly, right? And so after we hit the end of the array, because this will cover every case, we want to do for I in range in the length of nums. If num sub I does not equal to I, then we want to return I. So for example, we'll use this one, right? Because it's the longest, it probably will give us a good representation. So after we sort, nums will equal to 0, 1, 2, 3, 4, 5, 6, 7, 9. Because there's no 8. This helps us because we know there's no 8, but you know, we could have figured that out ourselves as well. So basically, if num sub I does not equal to I, so like I mentioned earlier with when we would want to swap, if I equals 0, then we want to see the number 0, 1, 2, and so on, right? So when I is equal to 8 here, we know that that's not right, so that's why we want to return the number 8. And so if, let's say for example, in this problem, we actually had all of the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, but we want the numbers from 0 to n, where n distinct numbers, right? So basically, we have 3 distinct numbers, so we want 0 through 3, which means we are missing one number here, which is 2. And so since we have 9 numbers here, right? Yeah, right, 9. We want 0 through 9, which would give us, we want like 10 numbers, and we're trying to figure out which one's missing. We know that since all of these are in the right place, that means we're looking for the missing number here, which is 9, right? So at the very end, if we don't return it, you know, any earlier, then we want to return here, we return the length of nums. So let me just remove that, and that should be the right answer. Nice, there we go. Yeah, that is the problem. Thanks for watching.